Hi, welcome back to Learn a Lot. In this video, we're going to look at proof by contrapositive. So we're going to expand our repertoire of mathematical proof beyond direct proof. And the example we're going to look at to better understand contrapositive proof is the following. Let's suppose that n is an integer. I want to prove that if n squared is even, then n is even. So this looks very similar to what we wanted to prove in our first video on direct proof. But it is slightly different. Here I can only assume that n squared is even, and I have to show that that means n is even. And it's worth taking a moment to think if we don't immediately recognize that this is a very different statement. We're not supposing that an even number, when you square it, remains even. We're trying to prove that if a number squared is even, the number is even. So it is a different statement. It's kind of the other direction. Now, if we try to prove this directly, we quickly run into an issue. Let's just have a go. Let's assume n squared is even. We know that that means there exists some other integer such that n squared is equal to 2m in this case. I've chosen m again. And now I need to show that there exists some other integer such that n is equal to 2 times that integer. But since we're going in the other direction, we can't pull the same trick we did last time because we're starting with n squared equals 2 times something. So I can't exactly, if I take the square root of both sides, so if I take the square root of both sides, I end up with the square root of n squared, which is equal to n, is equal to the square root of 2m. And here, where do we go from there? It didn't give us what we wanted, like it did in the other direction where we had 2m, we squared it, we got 4m squared, and that's 2 times an integer. Here we don't have 2 times an integer. So in this case, it seems that direct proof is kind of broken down. But by using this clever trick, proof by contrapositive, this is actually going to be very easy proof. So what is a proof by contrapositive? Here is the main idea. If I have some logical statement I'm trying to prove, let's say it's if some condition is true, let's call that A. So if A is true, then B is true. So if A is true, then B is true. That's kind of the logical statements we've dealt with so far grammatically fit this form. The main idea of a proof by contrapositive is that this statement is the same thing as the following statement. Not B, or let's say B, the statement B being false, so B false, implies that A is false. And this is something where I found I kind of had to meditate on the idea for a bit before I really believed it. And once I really believed it, I could confidently use it in proofs when I felt it was necessary. But I did kind of have to meditate on it for a bit to realize what this is really saying. So in our example, our A implies B statement is if n squared is even, then n is even. Proof by contrapositive is telling us, look, you tried proving that and it wasn't great, but you know what? That's the same thing as the following. That's the same thing as saying if n is odd, then n squared is odd. And in this case, n odd is our not b, because b being true is n being even. So b being true is n being even. So b being false is n being odd. If a number's odd, it can't be even. So proof by contrapositive says if you don't want to prove if n squared is even, then n is even, instead prove if n is odd, then n squared is odd. And it is a confusing idea at first. So I'll give you a bit of a indication for the kind of meditation I went through to understand it. And it involves some double negatives, so do your best to follow along, but it does sound a bit weird. So let's say we have this. So not B implies not A. So not B tells us for sure we have not A. This means that if we have A, so if we have A being true, we can't have not B. We can't have B being false if A is true, because B being false implies A is false. So if we have A, we can't have not B. Kind of a double negative there. And the trick is that can't have not B is the same as we have B. So B is true. So let me write that out in one more way just in case, because this is a subtle idea and it can take a bit to get. So B false implies A false. So if A is true, B can't be false. And can't be false is the same thing as B being true. So if A is true, then B is true. This kind of thinking is what's happening behind proof by contrapositive. Why it's saying that these two statements are in fact equivalent. All right, and with that out of the way, let's do our example. So we want to prove if n squared is even, then n is even. We are going to prove this by the contrapositive. So we might write, we prove the contrapositive. So it's called the contrapositive because it's kind of in the other direction with the opposite logical implication. It's that kind of mirror image logical statement. So we prove the contrapositive. So what we actually want to prove is if n is odd, then n squared is odd. And here, we've actually already proven this. We proved this in the last video. So contrapositive allowed us to take this new statement and realize it's equivalent to an old statement we've already proven. So we don't have any further work to do. So note that by the same method, we also know that if n squared is odd, then n is odd. By the same methods, we also know this is true because we've already proven the contrapositive of this statement. So hopefully you found that interesting, and I'll see you in the next video where we look at a proof by contradiction. Until next time.